The natural gas dissolved in oil is the source of energy for a solution gas drive reservoir. As oil is produced, the reservoir pressure drops. Once the bubble point pressure is reached, the natural gas dissolved in the oil will come out of solution and form bubbles, which expand as the fluid pressure is reduced further. The expanding bubbles continue to support production until they reach a critical saturation, the saturation where they join together and begin to flow as a single gas phase. Now the gas phase, because of its much lower viscosity, begins to flow to the wellbore much more rapidly than the oil. More and more free gas is produced with the crude oil. This causes the reservoir pressure to drop, and this finite energy source is rapidly depleted. Ultimately, the well ceases to flow. The range of oil recovery, expressed as a percentage of the original oil in place, is generally between 12% and 37%, with a median value of 20%. In effect, this means that on average we will leave 80% of the oil in the reservoir. This is certainly not very efficient. The proper management of this type of drive requires that we maintain the reservoir pressure above that of the critical gas saturation as long as possible, often by injecting a less expensive fluid into the reservoir to replace the hydrocarbons being recovered.